Let's do the proof for our law of cosines. We talked about before, we dealt with when we get two angles in the side, we can handle that with law of sines. And when we get an angle, then two sides, we can also handle that. But side angle side was one of the ways we just don't have the tactics yet. So this is how we're going to build it. So we're going to take a triangle like we've been talking about, little A's, B's, and C's in there. Except this time we're going to lay it out on the XY graph. Where we're right here, that's the origin, 0, 0. Everything's up here in the first quadrant or on the quadrantial angle. We got to point another vertex right there at A, 0, because that length is A. And then we have another vertex up top. We'll talk more about that. As I said, we're going to want to think side, angle, side. And what do we do when we know the side, an angle, and then the other side that traps that angle? What sort of information can we get? And we find that this is going to help us to find the side opposite the angle. So we're going to do a little proof, show that it works. By putting it in the first quadrant, labeling things, doing a little bit of algebra, things are going to get pretty fancy. So hang on. Let's get rid of all of this. And we're going to drop a perpendicular. So drop a perpendicular down. And I'm going to move this A out of the way. Just get it out. And just make a length. Let's try and figure out what this point is. And the x value would just be the length here, the x value. This length would just be our x from here to here, right? That's x. And then that height, the height like this, that's your y. Fair? Fair. So let's talk, what's our favorite? Let's talk about sine for a second. So what's sine of our angle beta? Or why did I say beta? B. Trying to be all fancy. Sine, wouldn't that be our opposite over our hypotenuse, or y over c? Y over c. Hold on, I'm going to do the same thing with cosine real quick and see what happens. So now we want to say cosine of b, and that's going to equal our, what's that, the adjacent over the hypotenuse, or x over c. Well, I think we can actually solve for x and y in terms of b's and c's and that sort of stuff. So let's multiply them across right here. So we have c times sine of b is equal to that y value. Moreover, our x value is going to equal, we multiply that over, c times cosine of b. So let's rewrite these. Our x value, c times cosine of b, c times cosine of b, and our y value, c times sine of b. All right, that was a lot of work just to get those 2 points up there. So I'm going to get rid of this little perpendicular. Ooh, not that much, not that much. Let's just get rid of this. I'll leave some of the stuff in. But let's remove all the junk. Now, what we're going to want to talk about, how the proof is going to come together, is all through algebra at this point. We still have this, let me get this out and put this A back in. Oh, remember, we know these sides, we know this angle, and we're trying to get this B. That's our game. So since we want to get that B, let's treat it as a length from here to here. Let's treat this as a length. And we have a distance formula. The distance formula, what is that? It's equal to the square root, what is that, like x2 minus x1 all squared plus y2 minus y1 squared, or otherwise known as the Pythagorean theorem, where x2 minus x1 is just a, y2 minus y1 is just b, and a squared plus b squared equals, yeah. Okay, let's moving on. So what we're going to do is we're going to use the distance formula, calling maybe this one x2, y2. And we'll call this one x1, y1. And we're just going to plug it into that formula, and we're going to see what happens, except we're not going to call it d for distance. We're going to call it b. Let's go. Having fun yet? So we're going to say that b is equal to the square root of, and now I'm just going to start filling things in. So what does it say? x2, what's x2? That's c times cosine of b. Minus, where's our x1? That's a. We square it, and then we add it 2. All right, so what's our y2? C times sine of b. Minus our y1, that's 0, and we're going to square it up. Cool. We now have this value all in terms of this crap. And what's going to end up happening is through some fancy algebra, we're going to build the formula for the law of cosines. Let's get it. So let's expand this out. Now I'm going to go with the assumption that you know that we're not just going to square these components. So this is going to become c squared times cosine squared of b minus 2 times a times c cosine of b plus a squared. That's that first term. We square our next, we get c squared times sine squared of b, because that 0 won't make any difference. And we continue working down. There's a little bit of a cleanup here, because anytime I see a cosine squared and a sine squared, I start to get happy. And I think we can put these two things together. I think we can put those two things together. So let's put them next to each other, as such. And so c squared sine squared of b plus c squared cosine squared of b. Just put this one next to that one. Minus 2ac cosine of b plus a squared. Well, what we can do is we can cheat. Do you see? The c squared's on both terms. Do you mind if we just factor it out to the front? Let's just factor it out. Let's make our lives easier. Just go and put a parenthesis around the whole thing. There it is. Because what's sine squared plus cosine squared? Of any angle, that, as long as it's in both. Oops, I wrote a square here. I think I know I'm going to square at some point in time. So what we have is c squared times 1. So let me rewrite it as c squared plus a squared minus 2a cosine of b. Why don't we square both sides? You know what? What the heck? All of our sides are supposed to be positive anyway. We square both sides and we get the b squared is equal to a squared plus c squared minus 2a. Wait a second. 2ac. I lost my c. 2ac cosine of b. And there is our law of cosines. But there's actually going to be 3 different formulas because a's, b's, and c's, they're arbitrary. They're completely arbitrary. So let's see if you can't catch the pattern. Let's see. So I'm going to say we're going to go for c squared now. See if you can't match the pattern. So it's going to be the two things that's not c, right? A and b. So it's going to be a squared plus b squared. And then next it's minus 2 times whatever those two things were, that a times the b, just like above where it was the a times the c. And then it's cosine of the angle that's opposite whatever we're solving for on the back end. So this one's going to be c. There's 1. Now let's go get the a squared. See if you can't catch the pattern now. Right? It's going to be the other two. B squared plus c squared minus 2 times those other two. Times cosine of, look to the front, a. there's the three formulas. They all come from frickin' right angles and playing frickin' games with them. So whenever you have a word problem and you're stuck and you don't know what to do, you can always make right triangles. It might be long and arduous like this was, but here is our proof of the law of cosines. We'll be back with a little bit more examples of things that you'll be expected to do. See ya.